So superposition. If we have two light sources, how do they combine, essentially? The principle of superposition says that when two waves meet, they can either constructively interfere or destructively interfere, and it is the sum of their individual components. So if I pick a point, if I've got sort of two sources of waves, and they're like ripples echoing out, and I pick a point where they're both going to strike, if they're both at peaks at that point, great. I will form a super peak of double the height of, let's say both peaks are of equal height. But if a peak meets a trough, oh dear, they'll cancel out. Former case is constructive interference. The latter case is destructive interference for reasons that hopefully are obvious. Interference is the superposition of waves to form a resultant wave. So yeah, on my right here, these are my resultant waves. And if we look at the pattern, the wider pattern, rather than a single point, we look at the wider pattern it forms on a screen. So instead of looking at a certain point, I put a screen here. I say, what is my screen going to look like? Is it sort of uniformly illuminated? No. It ends up forming these interesting fringes. Diffraction through a double slit, Young's double slit experiment, famous historical experiment, acts as dual coherent wave sources. So you get a light source, we pass it through a filter. So that it's all the same frequency. We use the first slit, which in itself is an interesting experiment, and it forms a fringe pattern normally, but we're just using it here as a source of diffraction. So it spreads out wide enough that we can illuminate both these holes. Great, good job. So don't focus too much on the first slit. Think about the two slits then. They're both narrow enough that diffraction occurs. And there's this fascinating region of crossover. And it's there that we see this interference pattern. To explain this fringe pattern, we've got to consider phase difference. Sorry, just to further explain what's going on. So that's my screen. And those are my dot slits. Phase difference. Pretty early on in the day, we did a little definition as part of an exam question about phase difference. And I think it's always a tricky concept to fully articulate. It's not necessarily a tricky concept to get your head around, but I just think it's a little bit clumsy to articulate. When we talk about phase, we are talking about, it's a measure of how far through a cycle, a repeated motion something is. So whether you're going in circles or as you're part of a sinusoidal oscillation, you can split that oscillation, which is going on, it's just repeating over and over again, split it into 360 little chunks, i.e. degrees, or you can split it into 2 pi chunks, i.e. radians. Why would you want to split it into 2 pi? That's a horrible number compared to 360. It's because it makes your maths in terms of trigonometric functions a lot more friendly, but we'll get into that. Either way you do it, whether you split it up into 360 pieces or 2 pi pieces, that's what the phase is fundamentally. It's just a measure of how far through, how far through that loading bar you are of each wave. Phase difference then is if you have 2 points on waves, if one's 80% done, one's 20% done, the phase difference is 60. But instead of percentages, we're not expressing it out of 100, we're expressing it out of 360 or out of 2 pi. Okay, so, a slightly strange concept, but useful nonetheless. When waves do arrive in phase, regardless of their amplitude, so you could have 2 waves that are in phase, So the leading edge of them is they reach peaks together, they reach troughs together. Great, they're simpatico. They've got the same frequency as well, so they stay in phase. They might have different amplitudes. One might be a huge wave, one might be a tiny wave, but they're still in phase. So when they do arrive together, constructive interference happens. You form bright fringe. They add their amplitudes and form a brighter bit than either one of them could have formed on their own. But when they arrive in antiphase, so in other words, when one is at a peak, the other is always at a trough, and vice versa, then they'll cancel out entirely, assuming that their amplitudes are the same. If their amplitudes are different, then it is a bit more messy. But from now on, let's assume the amplitudes are the same. When waves arrive out of phase, destructive interference occurs, giving the dark spots on the pattern. Okie dokie. Exam question, statement question. Define the terms coherence and phase in reference to waves. So phase, hopefully we're well equipped to talk about. The coherence, see if you can race me and give me a little definition. 1 mark for each definition. It's waves, you know that just because those words are only ever used in the context of wave physics. Coherence. If two sources are coherent, they have a fixed phase difference. Yeah, that's more or less the definition. Fixed phase difference between two waves of the same wavelength. Phase is an angular measure of a point on a wave through its wave cycle. Yeah,